Welcome everyone. In this tutorial, we are going to design and simulate a microstrip directional coupler using Keysight Advanced Design System. Before we start the design, let's first understand what a directional coupler is and why it is so widely used in RF and microwave engineering. A directional coupler is a passive 4-port microwave device that couples a small portion of the input signal while allowing the remaining power to continue to the output. It is widely used for power monitoring, signal sampling, VSWR measurement, radar, satellite communication, and RF test systems. In this tutorial, we will design a microstrip directional coupler in Keysight A D S, perform simulations, and analyze its performance using S parameters. So let's begin. First, create a new workspace. Next, create a new schematic. From the left component palette, navigate to T-Lines Microstrip and place a microstrip coupled line MC-Align component onto the schematic. Also place microstrip line, set the width 0.3 mm and length 3 mm. Set the width of the coupled line to 1.1 mm, separation 0.4 mm and length 7.6 mm. Use the copy-paste command to copy a microstrip line. Again adjust the length and width of microstrip line. Now, place a microstrip step component between the transmission lines and the coupled section to model the width transition. Connect all the components using the connect command, ensuring that every port is properly connected. Next, place a 50 ohm termination at one end of the circuit. Use F5 to adjust the text position. Use the copy and paste commands, and then apply mirror across Y-axis to flip it horizontally. Again press F5 key to adjust test position now. Search for microstrip bend and place into the schematic. Set the width 1.1 mm and bend angle to 90 degree. Place a microstrip line. Change the length to 5 mm. Now again use the copy and paste commands. And then apply mirror across Y-axis to flip it horizontally. Again press F5 key to adjust test position now. Place the remaining terminations at the other 3 ports so that all 4 ports of the directional coupler are terminated with 50 ohms loads. Now, place a S parameter simulator into the schematic. Set the start frequency to 7 GHz and step to 1 MHz. Once the schematic is complete, we will proceed to define the substrate. Place a microstrip substrate. Set the substrate parameters. I am using Rogers 5003C, whose thickness is 0.508 mm, permittivity is 3.55, as conductor is copper. So use conductivity value of copper and copper thickness to 35 micrometer, tangent loss 20.0027 and roughness 3.4 mm here. Now run the simulations. After the simulation get completed, a tab will open. You can plot parameters of your interest. I'm interested in return losses. And I am also interested in S21 and S31. Place the markers. Observe that return losses are better than -20 decibels at around 8.5 GHz. And forward insertion loss is better than 1.5 decibel, and insertion loss at coupled port is around 16 decibels. You can further optimize the results by tuning. For this, place a variable option. Add variables by double-clicking. Add a equal to 3 and b equal to 0.3. To use these variables for length and width, click on Tune option and select the variable for tuning. Now tune the variables to get desired results. Now you can generate a layout from the schematic. For this, go to Top menu in Layout tab and click on Generate or Update a Layout option. This will create an updated layout, but you see text size is too much large. You can change the text size by going in Preference option.